Hello everyone, welcome to the class of inventory models. We have already learned that inventory models are classified into two, deterministic and probabilistic models. Under the deterministic models, four sub-cases are there. The first case we already learned, infinite production with no shortages. Today we are going to study the second case, that is the finite production with no shortages. In this case, the demand is uniform and finite production rate is also given. The P is called the production rate and D is represented a demand rate. The equation is, there is a small change in the equation of Q optimal. Q optimal is equal to square root of 2D CO divided by CH into square root of P divided by P minus D. TIC optimal or total cost in total inventory cost equation is equal to square root of 2D COCH into square root of P minus D divided by P. This is the equation using under the case 2. Next we have to solve a practical problem in this case. This is the question given under the case 2 model. A contractor has to supply 10,000 paper cones per day to a textile unit. He finds that when he starts a production run, he can produce 25,000 paper cones per day. The cost of holding paper cone in stock for 1 year is 2 paise and the setup cost of a production run is rupees 18. How frequently should production run be made? Here in this question the carrying cost is directly given. It is 2 paise per year. In this question all other items, that means here the D is given 10,000 and the other items production run are given. All these are given in daily basis. Therefore we convert the carrying cost into daily cost. If we convert it into daily cost, divided it by the amount of 2 paise with 365, then we got the amount 0.000055 rupees, 0.000055 per day. Next ordering cost or CO is equal to rupees 18. 18 is given in the question. Next D means annual demand. Here it is given in daily basis. D is equal to 10,000 and P means production rate is 25,000. We use the equation Q optimal is equal to square root of 2D CO divided by CH into square root of P divided by P minus D. Then we got the answer 1,04,446 paper cones. Q optimal is equal to 1,04,446 paper cones. This is the optimal order number, but we want to know how frequent should production run be made. It means the time interval. Therefore we compute T optimal. T optimal is equal to Q optimal divided by D. Q optimal is 1,04,446 divided by D is 10,000. Then we get answer 10.4 days. Then we can say that the production run is to be made at an interval of 10.4 days. Okay.